Hello students, welcome back. And now we will see how to analyze circuits which are having one resistor, one capacitor minimum. So these are called first order circuits. So first order circuit will be basically having a first order differential equation, and how that equation will come, let us see. So I am having one capacitor and one inductor, and there is no voltage source or nothing, and we can say that initially there was some initial voltage across it and now it is discharging. So what is the equation for current in the resistor, or current across the capacitor, or voltage which is appearing across the capacitor? These are the parameters that we can find. So this is called a source free circuit. Now let us take this circuit and we can simply apply KCL, that means IC plus IR is equal to 0. When we do that and we go through some very logical sequence of derivations, we find that voltage at any time across the resistor or capacitor, because both of them were parallel, is V naught e raised to power minus T by RC. This is very easy derivation. You can go through it. But now this is our answer. Now let us focus on this equation. Now this equation, if I replace R into C with tau, can be written as V naught e raised to power minus T by tau. This tau is called time constant. So this tau basically decides how slow or fast the voltage across capacitor or resistor will discharge. So if I take this equation and I put T equal to tau, that means it will be e raised to power minus T by tau, and T is tau, that means e raised to power minus 1. So that means I can say that V of T at T equal to tau is 0.638 V naught. And if I put tau equal to 2 times T and 3 times or 4 times, then I can see that there is a further decay. And at almost 5 tau, this is almost just 0.6%, that means almost decayed. So we can say in time t equal to 5 tau, the capacitor will be fully discharged. Theoretically, it will take infinite time to discharge, but we can say practically in 4 tau or 5 tau, it is almost discharged. So this is the importance of tau. That means if you keep the value of tau to be smaller or larger, then your discharging time for the same circuit can increase or decrease. Tau is equal to RC. If this number is higher, it will discharge slowly. And if this number is lower, then it will discharge fastly for the same value for the same circuit. So if you change either R or C, one of them, your charging or discharging rate will increase or decrease. So when we talk about RC circuit, the only two parameters we have to focus on is V naught and tau. Where V naught is the initial voltage across the capacitor and tau is the time constant. Now let us take this example. We are saying that this is a source free circuit because there is no source attached. There are two resistors here, one capacitor here, one resistor here, and we are asking what is this Vx, what is this Ix, or what is this Vc as a function of time. Initially the voltage across capacitor is 15 volt. So we got a problem. Now first of all, we need to find V naught. V naught is given to us, that is 15, which is the voltage across capacitor. We are fine. But what is R into C? C is known to us, 0.1. But what is R? R is the resistance which will be appearing across this capacitor. So now find out the equivalent resistance which is going to appear across this capacitor. As I can see, this 8 and 12, they are in series, so they will make 20. And this 20 and this 5, they are parallel to each other, so then they will make 4. So then I can say that the whole circuit is one capacitor and one resistor of 4 ohm in parallel. And now we are back to the same question that okay, I got R, I got C, that means I can calculate my tau. Tau is R into C, that means 0.4. I already had the value of V naught, and then I can get easily that V naught e raised to power minus t by tau, 0.4 in the denominator will become 2.5 in the numerator. So this is my voltage across capacitor. Now come back to the question. If I am asking what is the voltage across 12 ohm resistor, well, 8 ohm and 12 ohm combined is parallel to capacitor. That means whatever is the voltage across this capacitor, the same voltage is across the series combination of these two. So what will be the voltage across 12 ohm alone? That will be 12 by 20 of whatever is the voltage across capacitor. So that will be 12 by 20 of voltage across capacitor. So if this was 15 e raised to power minus 2.5 t, so it will be 9 e raised to power minus 2.5 t. The next question we can ask, okay, how much current is flowing in this branch? Well, the voltage in this whole branch is 15 into e raised to power minus 2.5 t, and what is the total resistance of this branch? That is 20 ohm. So I could have easily divided, or the other way, you take this voltage Vx divide by 12 ohm. So both of them are fine. So you got current also. So that is how we will handle the first order RC circuit. Our focus will be only on two parameters, V naught and tau, which is RC. Once we are able to get these two quantities, rest of the things can be easily derived. So this is a very similar problem. Let us look at this one. So we are not giving any initial value. So we are saying this switch is closed and then it will open. So when this switch is closed for infinite time, as we said, capacitor will behave like open circuit. So capacitor will be open circuit. Whatever, and when I open it, that means no current is flowing in 1 ohm. So this is also gone. So voltage across this capacitor is same as voltage across 9 ohm. And how much will appear across 9 ohm? 20 volt is connected in two series combination of 3 and 9. That means the voltage across 9 ohm will be 9 by 12 of 20. So I easily got the 15 volt as my initial voltage. Once I open this switch, that means 3 ohm is gone, 20 ohm is gone, 20 volt is gone. So now I am left with 1 ohm, 9 ohm in series, and both of them parallel to 20. That means R is 10 and C is 20 millifarad. With this information, I can calculate tau. I got tau. So what is Vt? V naught e raised to power minus t by t. V naught was 15, and this is the answer we got. After that, if I ask any other parameter like what is the current in this or how much voltage is across 1 ohm, we can easily derive. So this is about first order RC circuits without any source. Keep learning. Thank you.